Hello, I'm Glenn Darling from the Open Horizon team, and I'd like to tell you about a utility that I built called the MMS Helper, which I think is an easier way to use the Open Horizon model management system. And if you don't recall what the model management system is, it enables you to have independent life cycles for your code and your machine learning models or any large data file. And it means that your code that you've already deployed in a Docker container onto your edge node, it can continue to run all the way through a model update. It doesn't need to stop running. It can continuously provide service to its clients and just switch to the new model whenever the new model arrives. And the components of the model management system are the Cloud Sync service and the Edge Sync service. And typical usage is that on a machine that is not your edge node, you would use the Open Horizon CLI, the HCN command, to publish a data file to the CSS. And then behind the scenes, the CSS will reach out to all of the appropriate agents on all of the appropriate nodes in your fleet, and it will interact with the Edge Sync service to deliver the file to those machines. Then on those edge machines, you will need to use the ESS REST API to copy the file into local storage in your container's file space. Now, that last step is somewhat onerous, some people have been finding. So I built this little MMS helper to simplify things by doing the last step for you. And let's talk about how that works. So just like before, you'll need to use the HCN CLI to publish your ML model to the CSS. And just like before, the CSS will deliver the file to the ESS based on the deployment pattern or policies or the list of nodes that you specify when you do the publication step. On your edge nodes, your code, which is the consumer of the ML model, it will need to mount a shared volume if you want to use the MMS helper. And your deployment pattern or policy must include and configure my new MMS helper service, which will mount the same shared volume. Then the MMS helper will continuously monitor the ESS REST APIs, and whenever a new ML model file is available, the MMS helper will download the file, but it will put it into the shared volume. That means that your code simply needs to watch for files to appear in the shared volume and act accordingly. So there's no need for your code to interact with any REST APIs. It just looks at the shared volume. When you publish a file, you need to specify the object type, and this can be just any string that gives an appropriate name to the type of files that you're publishing, and an object ID. And this object ID will become the file name of the file when the MMS helper writes it into the shared volume. So generally what I do is I just use the name of the actual file when I set the object ID. And of course you need a reference to the actual file so the HCN CLI can provide that file to the CSS. And you need to specify the target, as I said before, either pattern policy or a list of nodes. Then to deploy your consumer code, the code I show in green on the right, you need to modify the deployment string so that it binds that shared volume. And the MMS helper must also bind the shared volume, but I wrote the MMS helper, so I've taken care of that part for you. And the MMS must be configured with the object type to watch for. So whatever object type you used in the first step on this page for publishing the file, you need to provide that as configuration to the MMS helper so it knows what to look for. And another technical detail here, the MMS helper has to be a top level service in either your policy or your pattern deployment. And this is because the node agent only provides ESS credentials to top level services. So that's just a technical requirement, and that affects how I've structured this. And in the way that the MMS helper is set up, you will specify your consumer code as a required service of the MMS helper. So the MMS helper will be the top level service, and it will pull in your consumer code, even though it doesn't use any of the APIs in your consumer service. Some details to clarify here. The files will only appear in the shared volume when they are complete. You'll never see the file as it's being written to the shared volume. Now, to be more precise, I put a little note at the bottom. The files are initially downloaded into a hidden Linux file, in other words, a file that starts with a period. And then when the file is complete, then it is renamed to the file name of the object ID. But that happens only when the download is complete. So as long as you're not looking at files that start with a period prefix, which you would normally ignore on a directory listing on a Linux device anyway, but as long as you're not seeing the files that start with a period, then you will only see the file when it is complete. And files appear in the shared volume using the object ID you specified at publication time as their file name. And so your code simply needs to scan the directory where the shared volume is mounted into your container in order to notice the new object IDs arriving. And also, please note that once the file appears, you own it. The MMS helper will never again act on that file. It won't clean it up, it won't edit it, won't modify it. The ESS will have been told that the object was received, and then you can feel free to delete the file yourself once you've consumed it, or you can leave it on the shared volume and use it there, which is, I think, the more likely scenario. That you would continue to use it there until another one comes along and you want to switch over to using that one. So even after the file is delivered, the MMS helper will continue watching for new files of the specified object type, and it will act accordingly when they are available. So here's some more detailed steps. So of course you need to write some code in your consumer container that looks at the shared volume, that does an ls essentially on the shared volume to see what files are present, so it will notice when new files show up. But you also need to modify the Open Horizon metadata, and specifically the deployment string in the service definition has to bind the shared volume. So you'll need a line that looks like the one I showed there, binds, and then quote a shared volume name, and then whatever directory you want to mount it at within your containers file system. Then you need to build, push, and publish your consumer service, of course. And the next step is to clone the MMS Helper repo, and I'll go through that actual hands-on demo in a moment. So git clone github.com the mosquito MMS Helper. Then in that repo, you need to cd into the repo and then edit the make file in the repo. And there's 5 lines near the top of the make file, the first non-comment lines in the make file. You need to edit those. So you need to specify your service name. So it just says consumer here, but whatever your consumer service is called, and your service version, whatever your service version number is. So these are the Open Horizon service name and Open Horizon service version. The service name, or it's the URL field in the service definition of your service. Those two need to be specified because the MMS Helper service needs to specify your container as a required service. Then you also need to specify the shared volume name, and I recommend that you just use a simple name here. You could use a file system path, so slash temp slash foo or whatever, but if you use a file system path here instead of a volume name, then you need to ensure that it's writable by all these processes. The easiest way is to just use a name, and then the agent will create a Docker volume for you and mount it in both of these containers. Then you need to specify your object type, and again, that can be any string that you want to use, and it's the string that you use when you publish using the HCN CLI. And then lastly, you need to specify your Docker Hub ID, because your containers need to be pushed to a Docker repository of some kind to be able to be deployed by Open Horizon. Then you just build, push, and publish the MMS Helper service. So make build and make publish service, and the publish service will take care of pushing it to Docker Hub for you. So note that at the very top of the page, I stated a couple of prerequisites. Top right here, that you have to run HCN key create first to build your own signing key for cryptographically signing your workloads. And you need to Docker login so that when it attempts to push to Docker Hub, it will succeed. And then the last thing that you need to do here is to publish a policy or a pattern with the MMS Helper as a top level service. And remind you, it has to be a top level service. So I have an example pattern that does this, that just includes the MMS Helper, no other services. And so you can do make publish pattern, and it'll publish that example pattern. And then the MMS Helper will be requiring your service, so your service will be brought in automatically. And once you've done those 6 steps, then you'll be ready to register nodes and publish ML model files out to those nodes. Okay, so now let's get hands-on and I'll show you a quick demo of all of this stuff. Okay, so here we are on my edge node, and I've got 3 terminal windows open onto this edge node. The bottom one in yellow shows the output of the docker ps command, and it's running it every 2 seconds, so you'll see continuous updates here to show you which containers are running on this machine. And the top right window in green is doing the same thing, except running the hcn agreement list command over and over every 2 seconds. So we'll see the agreements being formed over here, and then eventually we'll see the containers running down here. In the upper left is where I'll be running most of the commands that I run. So the first thing I'm going to do here is to clone the MMS Helper repo and cd into there. Now notice that there's a couple of things that start with my, and I've used my as a convention of something that you would need to replace. So in this case, I have a file that I'm going to use as a proxy for a ML model file. And it's just a little tiny text file that says hello world. And then I'm going to provide an example container that would be consuming this content when it's delivered, and it just runs this very small shell script. Let's take a look at it. And this is the entire code of that container. It runs over and over again every 3 seconds, and ls on the shared directory. Now you'll be wanting to do something like this inside your code, but this is the only thing you need to do in your code. You need to look in the shared directory, which I mounted as /shared dir. This is the shared volume mount point. You'll need to look in here and see when files show up, and when they do show up, you'll need to act. Now, in order to make that happen, you'll need to edit your service definition file so that it has a bind for that shared volume. And so I called the shared volume my MMS Helper shared volume, again starting with my, because you'll want to probably change that. And then I mounted it at /shared dir. You can mount it wherever you like. You will likely want to mount it read-write, because once the files are delivered here by the MMS Helper, it's your responsibility to do whatever you want with them. So if you ever want to clean them up, you're going to need to do that yourself, because the MMS Helper will never clean them up. So consume them, use them while they're there. When version 3 comes along, you might want to delete version 2, or maybe version 1 and keep version 2 around as a fallback, or I don't know, but whatever strategy you want, it's your task to do that. So I need to make this to build it and to publish it to the Open Horizon Exchange, and it's very tiny, and I've run it a few times, so it's all cached everywhere. So that service called My Example Consumer 100 AMD64 has been published to the Open Horizon Exchange. So normally you will have done that separately, but I just do it here because it's part of this example. Now the things that you do need to work on in here are the 5 variable names that I told you about. So the first non-comment lines in here, these 5 lines right here, you need to edit to refer to your container, your service, not your container, your name for the shared volume, and your object type, and your Docker Hub ID. So all these things, my example consumer 100, those are the way that I published the example container, and this is the name I used for the shared volume, and this is the type that I'm going to use when I publish an example. And actually these things you can if you want to use my little example, you can use my object file over here, and or you can set them to your own. But that's all you need to do. Now I can run make build, and you would first edit the make file and then do that, and then make publish service to put this service into the Open Horizon Exchange. And when that finishes, we'll have two services. We'll have the example service, which would normally be your service, and the MMS Helper service. Now we need a pattern, and you may have noticed there's pattern.json here. And the pattern.json is very simple. It just includes a single service, which is going to be the MMS Helper service. And the reason it only needs to include a single service is because the MMS Helper service includes your service. Remember, you had to specify your service name and your service version. It includes your service as a required service. So the pattern refers to MMS Helper, and MMS Helper brings in your service. Also, there's a couple of bits of information passed into the MMS Helper, and that is the object type, and so that is set in this environment, or this variable that's passed to the MMS Helper, and the MMS Helper volume mount point, which is the place where this bind is going to mount it. Since I set this to shared dir, there's no way inside the container to know that it was stored in shared dir. So you can either hard code this in your code in the shared in the MMS Helper, or I just pass this in as a variable, and so the MMS Helper gets it from this variable. And so again, just skipped over that too quickly, but the bind here is a read-write bind on the MMS Helper shared volume. So we can actually write files in there. So we did make publish service. Now we need to do make publish pattern to publish that very simple pattern. And now at this point, it's completely ready. So you can do whatever you want with it. So I'm going to do make register pattern, which will register this edge node to run that pattern consisting of two services. And then soon enough, we should see over here some action. So the agbots in the management hub that I'm registered to, they will reach out and propose. So there's a proposal from the agbot, and then soon thereafter, the local agent should accept that proposal. And then soon after that, we should see some containers running down here in the yellow window. So I'll just kill that. We've got the agreement rolling now. And I'm going to run something else over here. I wrote a little tiny program that you can use to monitor what's going on inside the container. Whoops, /watch.sh. So it is watching for the my example consumer container to be started, and once it does start, it pulls the container ID of that container, which you can get from down here, and it's going to use that to docker exec into the container. So it's repeatedly execing into the container and doing an ls on the shared dir to see if there's any files in the shared directory. And currently there's no files there. It's waiting on us to publish something. So now the next thing I'm going to do is to do make publish object, and that will use the MMS CLI command, the HCN MMS CLI command, to publish that little tiny file. So it executes this exact command, HCN MMS object publish, and it specifies the object type, which is my unimaginative type name here, and the object ID, also unimaginative, and then the file name, where it can read the actual data of the file, and then the target that you want to send it to, which I'm just going to use the same pattern that I used to deploy this code. So these things are up and running down here, and the agent is up and running. And now we just need to wait for a few seconds or maybe even a few minutes for the agent to receive information from the Agbot that this model file is available, and then to download it and then make it available through the REST API to the MMS helper. Then the MMS helper will share it, which it has done over here. So the shared volume has found a file, and the file name here is myObject0, and it's a huge 14 bytes. And so the next thing that it does in my little watch program is cat that file. So that file made it to the container. So all of these commands took place. You could just look at the code, I guess, for that. /watch. It uses docker exec to do an ls in the shared directory and a docker exec to do a cat of that file from the shared directory. So this is taking place within the context of that example container. And, of course, I could send another one and it would find another file in that directory and so on. So that is that. Let's go back to the slides to wrap up. Well, there we have it. You saw the use of the HCN CLI to push a model file, and then inside the consumer code, inside the context of that container, we saw the file show up a short while later, delivered by the MMS helper by talking to the ESS APIs. I hope you agree with me that this is an easier way to use the Open Horizon Model Management System. I'd welcome your feedback if you give it a try. My email's at the bottom of the page there, glendarling@us.ibm.com.